think we're good. There you go. So coming into, we got a little bit of a weak connection here.
Oh, you're not plugged in.
Oh, this was done. Sorry about this, folks. Yeah, I got it. There a second ago to come out. So coming into Developer Day, we had a number of questions about whether there be enterprise content at Developer Day, and it was clear that not everybody was aware that Google had an enterprise group and how enterprise really fit into our product strategy and our developer product strategy. So I wanted to back up a second and just kind of revisit Google's mission. I'm sure you've heard it a ton of times: organize the world's information and make it universally accessible and useful. But actually, these words were, as you might imagine, chosen quite carefully, and they're specifically relevant here. The world's information, as you might imagine, includes a ton of corporate information. So information in document and content management systems, in file systems, and databases, and business applications and such. So this slice of the world's information is obviously, it's so important to Google that we created this whole group, and that's the enterprise group, to specifically focus on it. So we want to give a quick shout out to Google Enterprise. So specifically, what we do is we take Google's core research and development and then adapt and deliver that innovation into the enterprise space. So we've been around for a handful of years, have thousands of customers. There's actually over 7,000 customers, and many of them going back multiple years, and ranging from SMBs up through the largest corporations. And then we actually work, sell into multiple product areas. These are kind of the major product areas. Like I said, we're going to talk about search, specifically our Search Appliance APIs today in this session. But one thing I definitely wanted to point out is, as you know, there's a ton of sessions going on in these other product areas today. Certainly in the geospatial arena with Maps and Earth, we've got a whole track on the APIs there. And collaboration, this really refers to our Google Apps product suite and the services that are part of that. The key thing that I want to point out here is that very intentionally, Google has made it such that the APIs that are available, the Maps APIs, but also the GData APIs and the Google Gadgets APIs. If you've attended Jeff's session this morning on GData, there's another session this afternoon on GData, and a great session on the Google Gadgets API later this afternoon. Those are directly relevant to Google Apps, and as a result, directly relevant to the enterprise space. So the key thing with these, from a developer's point of view, is a developer platform is essentially the same between the enterprise and the consumer or standalone applications. So you learn one API, you build one application, and it'll work across all these segments. The other thing I want to mention, consumerization of IT. This is really kind of a marketing phenomenon. It's become a bit of a buzzword phrase. But to me, what this really refers to is that this idea that enterprise software doesn't have to be extraordinarily complex, both from the end user standpoint, but also from the developer standpoint, from the API standpoint. And so hopefully, this has been a big driver for our growth within Google Enterprise, because a lot of our customers certainly really embrace with this. They say, oh, this is our search appliance, for example, is just not only the ease of use from the end user's point of view, but the ease of use from an administrator's point of view. It's really something that they're not really used to with enterprise software. But again, the message that I kind of want to bring into here is that the APIs that we'll look at here and the APIs that you'll see in different sessions today, we really want to bring that same ease of use and simplicity and intuitiveness to all of our APIs. In the case of our developer products, the user is the developer, and the focus on the user mantra that's pervasive throughout Google is certainly relevant there. Okay, so enough of that. What I wanted to do here was actually walk through an application development scenario, so a business application. So we're going to do a little role playing. So we are a application developer, an independent software vendor, could be an IT engineer or just a creative employee. But we built an application, and what we want to do is to better enable access to that application through search. Actually, so I want to back up 1 second. And one thing that we have to realize about our users, and these are our business application users, is that things have kind of changed thanks to the phenomenal success of web search engines like Google. users' expectations, consumers' expectations have really been raised, and the search box is no longer just kind of a feature that you kind of put up in the top right and fill up some dead space. But more and more these days, when people go to either a website or a web application, they're actually looking to the search box first as their primary means of navigation. And then, if they don't find what they're looking for, or they're not able to accomplish a task that they're trying to accomplish, then maybe they'll fall back to your fancy Ajax-based menu navigation and so forth. But they're looking to the search box first. And if they don't find what they're looking for, it's a good chance that they might actually even leave and not even bother digging into the application or site. The other thing about this is it's just as true in the world of business applications as it is in the consumer web world, which makes sense since the people, the consumers, right, at night who are using Google and using these Web 2.0 applications, the next day they're the same users or business application users. So it makes sense that they would have the same expectations and look for that same, look to use the applications in a similar way. Okay, so that said, here is our fictitious application. It's an applicant tracking system. So basically, it's an application for managing the hiring and recruiting process within our organization, Acme. As you can see, it's a typical enterprise intranet application. It's very data-centric. This particular UI layout isn't very task-oriented, but you can see there's different users. In this case, we've got hiring managers, we've got recruiters and recruiting coordinators, and we've got the actual interviewers that are going to come in here and provide feedback and so forth. And then there's various business objects. There's job postings and job requisitions. Candidates are submitting applications with resumes, and then interviewers are submitting feedback forms and so forth. So in this case, there's no search box yet. And you can kind of see this bright Acme Human Resources logo, front and center on the front page. Not a very useful dashboard landing page for people to go to get the information they're quickly looking for, but this is kind of typical with internet applications. Now, the business problem that we're trying to solve is that Acme is kind of growing fast and furious, and the hiring managers are having difficulty keeping track of their candidates as they go through the recruiting process. And the second thing is that there are different, hiring managers put out requisitions which turn into public job postings, and they're in different departments, and in a lot of cases they're asking for skill sets that are somewhat overlapping, and so as a candidate, I can apply for multiple positions, but those wind up taking me up into siloed pipelines where I deal with this hiring manager in this department and this hiring manager in this department. And so what you might find is, what they're finding is that great applicants are getting in and maybe being turned down by one hiring manager, whereas had there been visibility to another hiring manager of that process, had they applied for a similar position, they would have done just fine. And so they're losing great candidates because of this lack of visibility across hiring pipelines. And then we drill down into kind of our candidate profile. Got some interest from Ben Franklin. So we can see when we're kind of looking at this, there's a combination of structured data. So we've got the principals involved, the recruiters, and the interviewers and such, the hiring manager. And then there's unstructured data. So in this case, we've got resume, we've got an application that Ben has submitted, and there's interview feedback forms, review forms, kind of free-form information. And then lastly, actually, you can see kind of in red over there in the first row here, that there's a status, pending second offsite. So there's clear that there's, behind the scenes here, there's some sort of implied workflow going on, and that as a candidate goes through the process, that status is going to change. And you can kind of see a job requisition. Again, a job posting kind of starts life as a job requisition, but again, it's submitted by a hiring manager, and there's not a whole lot of visibility amongst hiring managers for these different jobs that they're putting out. Okay, so this is Acme's central intranet search page. So fortunately, they've actually got a Google Search Appliance. So for those of you not familiar with Google Search Appliance and Google Mini, this is our line of enterprise search solutions. We've actually got a yellow search appliance over in the demo pod near the mini kitchen out there. But essentially, these appliances, it's a combination of hardware and software bundled together. They live inside the firewall, and they maintain an index of all the corporate information that we talked about earlier. So your content management systems, your file systems, and your business applications, et cetera. So this, what we're looking at here is kind of other than the Acme logo, this is kind of the default search interface of the search appliance. So you plug it in, you point it to different places in your network, and it does some crawling, and you wind up being able to run searches and kind of see this interface. So as you can see, it's very similar to Google.com interface, and that's quite intentional. Users kind of, again, going back to the consumers, our business users, they know how to use that. They know how to use Google.com. It's intuitive, and we spend a lot of time and listen to a lot of user feedback to hone that interface. But as you can see, so I run a query on Java Engineer, and I get back a couple of documents. The first one from the application, this applicant tracking system itself. This is one of the requisitions that has been submitted. And then we can also actually, the appliance also actually digs into this PDF document. So this is a resume that Ben Franklin actually gave to us, and it was attached on the candidate profile that we saw. So what's happened up to this point is that basically since our application is a web application, the appliance was simply pointed at the root of that application, and then it's crawled through various hyperlinks. And it does really well with unstructured information like this, and so it's been able to bubble these documents up near the top of our search results. So one thing as I look at this, especially if I remove the arrows, you can see the information is kind of buried in there. It's not immediately, if I'm going in and looking for candidate information for the Java engineer position, it's not immediately obvious to me what I'm looking at here. And specifically, if we look down at that resume, second from the bottom there, I can't tell. I can tell it's a resume because it says that in the title, but I can't tell that this is a candidate that's in our recruiting pipeline. I can't even tell the candidate's last name, actually. But I can't tell, even if I knew the candidate was in the pipeline, I can't tell the status. I can't get at their application directly from here. What I'd have to do is open up this PDF document, which was sent to me by Ben, and copy out his name, and then do another search, or actually go into our applicant tracking system and pull that information out kind of in another step. So it's not a great user experience. So given that we've written the application, or we're writing the application, we have detailed knowledge of the data and the UI there. And we've got the search appliance with these APIs, we can actually do a lot better than this. So that's what we're going to try to do. So the first thing, we kind of saw that the appliance can actually go out and crawl. You don't have to do anything. It can go out and crawl content that you pointed at. But we can actually have better control over that by being able to proactively feed content into the search appliance index. So the way that you do that, again, trying to keep things simple, is that you simply send an HTTP post request with your content enveloped in an XML format to a well-known URI on the appliance. So the format of that XML can take various formats depending on what you're trying to do. So in this case, first scenario here is basically I just want to kind of give the appliance a set of URLs. These are basically start crawl URLs. So I'm going to take this, whether they're documents, just go ahead and capture this document. Or they could be a web page or a section of a website, and it's basically saying, hey, go and start crawling here. If we're familiar with sitemaps in the Google.com world, this would basically be the analogous to that, where you're basically feeding in this map to your application. Semi-interesting. But now, what we want to do, so backing up a second, when the appliance finds you feed a PDF document or an HTML document or an Office document, it'll automatically pull metadata out of that document. So if you're using, for example, Adobe PDF, you go into the file properties, and you can kind of see there's some like the author, and you can fill in various fields there. The appliance will get access to that information. But if you think about what's happening here, is this resume here was actually submitted by our candidate. And so the metadata in that may be useful to us, may not be. But we've got our application now, our tracking system, that on the back end is backed by some database. And so we've got other data in there, like the position that the applicants applied for. Maybe we've followed up and asked them for a photo. And we have with the hiring manager, we have various degrees of metadata that we can associate if we take into account this database, right? So we've got our document, and essentially what we want to do, and what we're able to do by just kind of creating this record element with this metadata tag embedded, is bind that metadata that's from this external data source, or it could be multiple external data sources, bind that metadata to this document in the search appliance index. So an example of how that could be useful, why that could be useful, is let's say now we want to, we're saying that this resume is associated with this position title. So it's associated with a candidate who's applying for this position. We could put a combo box, for example, near the search box and fill that combo box with all of our job positions. And then allow a searcher to be able to say, okay, I want to search through all the resumes that are of candidates who are applying for the Java software engineer position. You can also, that's one, you can also kind of, to a degree, tweak relevancy a little bit with metadata. But the other really cool thing that you can do is you can use this metadata on the front end to actually change the way that, that search results are displayed. And we're going to take a look at that, an example of that in a second here. The last thing you can do here is actually feed the content of the document itself directly into the search index. So for example, if your application is offline part of the time, or in some way it's not accessible to the Search Appliance crawler, or you want to control the feeding crawling process to a degree, you can basically paste the entire document directly in here. In this case, we've got, it's just an HTML document, but it could just as easily be a PDF, some sort of binary document where you just base64 encode the document, and then so it's printable text, and then you can just paste it right into a content element like this. So last thing that I wanted to kind of mention here is that this is kind of, we want to make sure everyone kind of knows what's going on at the HTTP level, so they can kind of go down to that level and be able to debug and just have peace of mind. As a developer, that's always kind of helped me to just kind of know what's going on. We've got, for all of these APIs, we've got Java-based abstractions, in some cases other languages as well, where you can use a much higher level abstraction framework. So for the feed and then for authentication, which I'm going to talk about earlier, we've got an open source project that's called the Google Content Connector Framework. And actually Max is here to maybe answer some questions and talk to some folks further about that. But if you've got an application that's not a simple web application like I'm dealing here, and maybe it's a content management application or collaboration application or something that's maybe more legacy and more ingrained into your enterprise, you can actually, behind the scenes, you're going to be doing this, but you can actually use a higher level framework to play with and actually allow administrators who are administering. Remember, I mentioned the web interface where you can administer your search appliance, or where an administrator would go in and manage search appliance. In that same interface, they can actually manage your add-on connector. So that's definitely useful. Okay, so put that together, and now we've got more control over the data that's actually in the index, and we've got this metadata that's now available at search result display time. So we can do something that's a little nicer. We can put our human resources logo up there, because we know that these two documents actually are sourced from that application. These are the same documents that we were looking at in the previous search results. The other thing we can do, if you look down at the bottom result there, is that we added this metadata. We now have this metadata available at search results display time, so we can display this is a candidate. They're applying for this position, and we can also put calls to action in there. So in addition to being able to go and click and view the candidate's resume directly right here in the search results, I can go directly to their candidate profile that we saw earlier with all of the structured and unstructured information, the links and attachments and such. Or I can go to the posting and so forth. So it's a very powerful way of combining things, and really you're combining things on input into the search appliance by binding this metadata to the documents, and then they're coming out the other end and providing a better user experience. And then get a little bit carried away, we can actually put the photo of Ben in here, but I don't think that's a great idea. Okay, so that's the Feeds API. Next thing that we want to do to kind of make this experience a little bit better is, we don't want, if a user is in our application and they're looking for information, we don't want to send them to the internet search box, go off to that site and then search for information, and then hopefully they find it in their results there, and they may, it'll be amongst other documents from within our corporate network. And then they're going to click on the document and come back into our application. We might as well just have them stay in our application the whole time. So we want to add a search box directly to our application. So adding search box, you kind of recognize this is going to be pretty simple. You basically just need to add a form with your text box and a submit button. In the case of the appliance, there's a couple of other parameters. But there's two things that I want to point out that we really need to pay attention to make this really useful. So the first thing is that we want to constrain the results to a particular slice of the index. We don't want to search across all of the index and get all the results that we saw earlier. we want to constrain and look at just basically a slice. So in the search appliance case, we call this slice a collection, and when we define it by URL patterns. So for example, in this case, I can define a collection called ATS, Applicant Tracking System Collection, and basically that's saying all of the documents in our index whose original source was under http acme.corp.com/ATS. So that'll constrain the results. So that's kind of half of the issue. But the more interesting question is, for those of you with an eye for the detail, kind of looking up top, can kind of see that we're actually submitting this form to a URI on the search appliance. So as soon as the user hits search, they're going to actually be directed to the search appliance, and we're going to lose control. They're going to go outside of our application. So there's a number of ways to get around this, and the way that I've for the simplicity of the presentation, the way that I've approached it here is to take advantage of the fact that with the search appliance, you can actually pass in with your search request, which is what's going to happen when you hit submit on this form. You can pass in a reference to an XSL style sheet, and then the appliance will run a search, formulate the search results, the potential search results as XML, and then run an XSL transform over that XML to turn it into a presentation HTML to send back to your application. So in this way, if you're familiar with XSL, you can basically take complete control over the presentation of these search results by basically passing in a style sheet here. Now this has some restrictions because it's still going to be served by the search appliance. So if your application is managing session state or something, if you basically want to actually keep the browser pointing to your application, then it gets a little bit less trivial because, but then basically what you can do is use your application server as a proxy for the search request to the appliance. So basically I would change the action parameter here. Instead of pointing to the search appliance, I'd be pointing to my ATS application. I'd pass the query there, and then my application server side would make a request to the search appliance that would look, the request would look similar to this, except that I'd remove that proxy style sheet parameter altogether. And the effect of that is that there wouldn't be any of this transform. It would actually send the XML results directly back to my server, directly back to my application server side. I can then consume those XML results, do whatever I want, and then return those results back to the user. So that's much more flexible. It's a little bit more involved approach. There's where I changed the proxy style sheet parameter. Okay, so for those of you familiar with XSL, you'll kind of recognize this. If you don't, you could probably follow along. But this is just a quick example. If you look about essentially what XSL is extensible style sheet language. Basically, it allows us in this case to take our XML, our search results, which is just the raw data, and then apply a series of rules which are defined in this XSL language to essentially transform that XML into presentation code, into HTML. So in this case, in gray, you kind of see these are the XSL rules. It's also got some references to the XML elements. And then in blue, you see the HTML. So if you look about halfway down, where we see that template match equals R, within that, we're basically writing out a link where the href attribute of that anchor tag is pointing to the URL of our search result. And then similarly, we put the title in as our label, as a label to our anchor tag. And then we can run through the meta tag elements. These are the things we kind of saw before: job candidate and job position. We can run through those, and in this case, we're just kind of writing those out in italics. So XSL is kind of, if you're not familiar with it, we use it a couple different places in the search appliance. We'll look at another area in a little bit, but it's a useful way. It's not the only way. It's certainly a useful way of providing complete control over the presentation layer to developers. Once you get the hang of it, it's not really difficult to work with, but the syntax can kind of get a little bit confusing, as you can kind of tell here, because you're basically working with two different languages, on the same page, same place. Okay, so you put that all together, and we get something that looks like this. So now we've got our search box up at the top. We're searching for Java Engineer again. And now you notice that all of the results are actually results that are sourced from our application. So they're all relevant directly to our application. So we've confined the results to this particular collection. And you can see that the metadata that we provided is still available. And then, so the interesting thing is, because I passed in the style sheet, this is actually still served by the search appliance. but the look and feel. So basically, in my XSL, I had to redefine all of the menus, the nav bar out there on the left. For the most part, that's going to be HTML. It's just kind of copied into my XSL file. Okay, so now we're able to run searches. We're able to get back results. We're able to have users stay within the context of our application. So next thing is restricted content. So in the enterprise scenarios particularly, everything is access controlled in one way or another. And so we've got to find some way of dealing with this. So if you notice that, can't see it too well, but in this whole scenario, our hiring manager has actually been signed into this application. And as a result of that, he actually has access to some things that other roles may not have access to. So you can see, in this case, he can see offer letters and comp terms and so forth. So how do we deal with this at search time? So one way of dealing with it is just to leave it out. So we're providing search across all this data. If certain parts of your application are secure, we're not going to get in there and we're not going to provide those results to the user. That's not really an ideal scenario. What we'd like to do, an ideal scenario, is to provide all of the results we'd like to provide the appropriate results to the appropriate user. So basically, you as a user can get access to everything that you're supposed to get access to and nothing that you're not supposed to get access to. So in our example, with this web application, a typical web application, this user has signed in through a login form. And his session state is actually managed through cookies. And for the sake of this example, again, we're going to assume that the cookie domain of the application and of our search appliance are the same. So what that means is that at search time, when they hit search, when it sends that request to the appliance, the user's cookie is actually sent to the appliance. So, we can spend quite a bit of time talking about authentication and authorization and access control and so forth. But for the sake of this, let's just assume that authentication piece is handled. In the case of web applications, it actually is pretty simple. Search Appliance has access to that user's cookie, so it knows who the user is. But it still has to get, back to here in a second, it still has to know, now for each result, that user is either going to have access to that information or is not going to have access to that information. So it still has to solve, what we call that that's the authorization problem. Is this user authorized to view this result? So we do have to come back to that. But going back to our search form, when the appliance crawls information or information is fed in, essentially each document is marked, or collection of documents by URL pattern are marked as they're either secure or they're not. They're either available publicly, or we have to deal with this authentication authorization question before returning results to the user. So you basically, when you're making a search request, you've got to specify, do I care about the entire index, including all the secure documents, or do I not even want to worry about that and only want to focus on the public documents? So that's kind of what this access parameter, and this is basically saying, I want my result, I want to have access to the entire index. I want to search across the entire index, including the secure documents. Okay, so now we're back to the question of authorization. And this is kind of the magic question that the appliance supports many different mechanisms for doing authentication and authorization. But really, the fundamental question that needs to be answered is that the appliance is going to go and formulate these search results. And before it sends those back to before it sends 10 or 20, whatever search results you're asking for, before it sends that back to the user, it needs to know, can this user view this document? Can this user view this document? So for each result, it needs to answer this question. And what we chose to do is to not have a feed type of API for this, where you can basically push all access control type information into the appliance, because that has all kinds of problems with data getting stale and that sort of thing. What we chose to do is to do this in real time. So at search time, you're going to submit your search. At that time, it's going to go and effectively either ask the source application, or if you've got a single sign-on system or something like that in place, ask this application whether this user has access to this result. In the case of our web application where we've got this cookie, what it's actually going to do is send a request to the source application. In this case, it's going to send a GET request with the cookie, and it's going to expect back an HTTP response code. And it's going to pay attention to that response code to determine whether we should show this result to this user or not. So you can kind of see, if we get back HTTP 200, great, we're not going to filter out this result. If we get back 401, or I think 403 forbidden will also work, then we're going to show this. Then we're not going to show this result. We're going to filter it out of the results. So one thing that a little tricky thing that folks seem to get caught by now and again is that Google, if you went to the GData talk earlier, we really try to play nice with standards. HTTP and the different response codes in HTTP are kind of pervasive throughout GData. similarly, we're trying to play nice here as well. And so typically, web applications, what they'll do if they present a login form like this and the user is unable to log in, or in our case, we've sent a request with a cookie, and let's say that the cookie is a bad cookie, it's expired, or the user's not able to access the page that they're trying to access. Many web applications will actually redirect to a login page like this. And so effectively, they're returning an HTTP 200 response code, but then showing a page with error information embedded within it. So clearly, the appliance can't figure this out, right? It's not going to go through and say, oh, well, this text is red, so it must be an error. Don't show this page. If the appliance gets back this result to this GET request, then it's going to interpret that as, great, we got back a 200 result, show this result, show this document to the user, which is exactly the opposite of what we want in this case. So that's something to be a little careful of. And what you can do is actually inspect the request headers to be able to tell the difference between, is this a request from a user trying to get access to this document, or is this an authorization check coming from, in this case, the appliance, but in general, you can figure that out from the request headers. Okay, so I put that together, and again, we're searching a Java engineer. We've actually got that. I've added that includes secure content checkbox at the top there, so basically leaving it up to the user as to whether they want to search across all content. But in this case, we're able to get back, because we've sent our cookie, it's authorized that this user is able to view this document with this candidate's offer letter. And so the user, seamless to the user, the fact that the user is logged into our applicant tracking system, our hiring manager is logged in, they're able to get back access to that offer letter without them doing anything special, credential-wise. Okay, so last thing that I wanted to talk about here is this concept of dynamic information. So if you've used, whether you realize it or not, most likely at one time or another, you've seen something like this on Google.com, where you run a search on weather, San Francisco, or on movies, or you put in a stock ticker. And what you get back is this display at the top of your search results that's a little bit different than the rest of the results. So in this case, I've got back a 4-day weather forecast. So we call this a one box. And there's lots of them. If you kind of dig through the About page, I think, on Google.com, you kind of, there's ways you can find out like all of the one boxes. But we really want users to discover them, like this. Hey, I'm looking for weather in San Francisco. Oh, great, there's an answer for me. But there's two things I want to point out about this. One, clearly this information, weather forecasts are changing all the time. This information is too dynamic for Google to index. It's just not practical. It's not something we want to do. So what's happening here is when we run this search, yeah, it's looking in the Google.com search index for all of these other results, but for this weather forecast, it's making a call out to a weather service and getting back that information in real time. There's caching and all that kind of stuff involved, but that's basically what's going on. The second thing is that whole process has obviously got to be triggered by something, and in this case, Google's recognizing that someone has entered this search query pattern, that they see weather followed by some location. So it says, OK, if you see weather followed by a location, then try and find this weather forecast and display this to the user. And you can see a similar type of thing with Fed. I don't know if anybody's tried this, but if you actually take a FedEx tracking number and paste it into Google, it'll recognize that pattern as a FedEx tracking number and display a link directly to the tracking page. So many people find this easier. If you've got a tracking number, got access to a search box, paste it in, click, and I'm at the tracking page. In a lot of cases, that's easier than going to FedEx.com and kind of digging through and finding the tracking page that way. So what we want to do is take this concept and bring it into our enterprise search scenario. So if you remember way back in the maybe one of the first few slides when I showed the status and that red text saying, OK, this candidate is in this pending approval or pending a second on-site interview status. So for the sake of this demo, let's just say let's assume that information, that status, is too dynamic for us to index, and we don't want it to get stale. We don't want people getting the wrong idea on the current status of an applicant, and so we want to create a one-box module to provide access to this dynamic information. So we're going to create this one-box module. Effectively, what you do is you create an XML file, simple XML file, looks like this. And then you distribute that, and an appliance administrator can take that XML and effectively install the one-box module in their appliance using just this XML file. What we need to do to define this is three things. So first, we need to find like a trigger. So we saw weather was a trigger for that one box. In this case, our use case is that we expect a user is going to go in and type candidate followed by maybe a candidate name, and that we want that to trigger our one box. So our keyword, our trigger is the term candidate. If we see that in a search, we're going to trigger this process. Second thing is that we need the logic behind the one box. So again, this is happening at real time when the user hits search. We're not going to look in our index for this information. We're going to actually call out to this separate component. Instead of a weather service, it's going to be this separate component that the one box developer writes. And the Search Appliance is going to ask that for this information. So in this case, we've defined this status provider. It's a servlet on our application server. And effectively, the appliance is going to make an HTTP request to that component and add in some user context, some request context, including our query. You can see the last parameter there, query equals Franklin. So I'm doing a search on candidate Franklin, and that's triggering this one box. This request is being sent to my servlet, and it's the job of the servlet to figure out, okay, what is the status of that candidate? And since it's part of the application that we've written, it should be able to determine that pretty easily. So you turn back some XML, well-defined XML, but it looks kind of complicated. But really what it comes down to is you're basically returning a set of name-value pairs. We look down at the bottom. This is basically saying for each result, we want to return this data. And so we've got the candidate's name, some IDs, but we've also got the third field down there is status. So we've got the status that we're sending back to the appliance. So again, you see like what's happening is the user has made a request to the search appliance. The search appliance has then effectively delegated that request to our one box component, which is now returning this XML to the search appliance. And then the last thing that we need to do, which is the third thing that I mentioned here, is define how's that data that we've just sent back, how is that going to be displayed? Right, so this is the weather forecast. How do we want to display this? And again, this comes back to XSL. Right? And again, it looks a little bit complicated if you're not familiar with XSL, but basically what we want to do is put up a table where each row in the table is going to refer to some data that's come back from our one box module. So we've got the candidate name in an anchor tag. We've got the status, which is really what we're looking for. And then we've got some other information, the last employee that's contacted this candidate. And so when you put it all together, you end up with something like this. So I've done a search now on candidate Franklin. And in addition to the normal results that I've got down at the bottom, I've got this one box display up at the top, which has got, it's branded with some image that we defined. And then it's got our metadata about the candidate, including their current status. So, for example, if a recruiter gets a call from this candidate saying, "Hey, I haven't heard back in 2 weeks. What's going on? What's my status?" Recruiter doesn't have to go log into the applicant tracking system and all that. They can just kind of find the nearest search box. What's your name? Franklin. Okay, candidate Franklin, and then get this information immediately right in their search interface. So that's kind of the overview of different Search Appliance APIs. As I mentioned at the top, we certainly deal with Google Apps is a big part of Google Enterprise right now, and certainly the APIs associated with that. I mentioned GData and Google Gadgets. Geospatial, the Maps APIs. We have a huge enterprise maps market. Lots of applications for applicability for maps and Earth within enterprise space, within specific verticals. We've actually got a large number of partners, ISVs, systems integrators, and so forth that we work with, and we've got a growing set of just independent developers, freelancers, and so forth. There is, as we continue to grow out our customer base, there's quite a large opportunity for developers that are just coming on, want to learn the APIs, figure out how they can either map that into their own applications or go into a new space to kind of build applications that fit these needs. I've been working, like I said, with these partners and developers for the past year, and I kind of have an idea of what makes some successful and some not. And it's really kind of obvious when you think about it. It's not very difficult. Basically, if you can figure out, if you can come up with some unique insight, be active in the user groups and the developer groups. If you've built something, share it with us. Obviously, you're going to share it with your customers. Share your successes. If you've got customer success stories, hey, we've deployed this. These guys are really happy with it. This is working. We're doing this for this person. It's working really well. Maybe it's unique. Maybe it's not unique. But you've had some success. We are basically looking to help you to market and promote your success, and we're certainly happy to do that using our Google.com properties. We've got a solutions gallery, again, that right now spans both search and collaboration, where we're specifically marketing third-party developers and the solutions that they've built, trying to get them greater visibility. And we'd be happy to put you up in there. And then for the most successful of our partners, we can kind of take it to the next level, which really allows us to provide really hands-on marketing and sales support. So you can build relationships with our sales folks. We can do co-marketing and seminars and so forth. And that's through a partner program that we call Google Enterprise Professional Program. And so, go through this, learn the APIs, build stuff, get it working, get some customers, get some successes, share it with us, and you can kind of build your business. And then, basically, we're here to help you snowball that. Okay, this I'm sure will be all available, but it's different APIs and different resources. One thing that we need to put on here is those Java abstraction frameworks. I mentioned the connector framework for the feeds, for essentially feeding content into the appliance. We've also got a Java abstraction for that search API. So rather than making XML search requests, you can actually manipulate Java objects to send that request and consume the results. And then on the one-box side, we've got a framework for creating one-boxes where you don't have to worry about the XML marshalling or any of that. You basically can sit down and implement your logic within a method. Most of, like I said, a lot of our sample code in these areas are Java right now. Partly because within the enterprise space, there's a lot more Java and .NET developers than we see Python and Ruby and some of these other client libraries that we see kind of sprung around these different sessions. But certainly, if you have interest in a particular language and you've built something, you've built a client library or something to make development in that language against these APIs easier, more than happy to promote that for you, put that on our site under your name. So that is basically all I had. So I wanted to open it up for questions. And again, we can actually do questions because I actually work with our Google Apps suite as well. We can kind of do questions across both search and apps. Yes?
What kind of cost should a small company expect to put this to work in their office, and also what resources should they expect to bring as well?
Great question. Okay, so I'll expand on that actually. So the first is the cost for the company, and then which wants to actually purchase a search appliance or a Google Mini. Then the other thing is cost for a developer. So I mentioned that this company has a search appliance in-house. How do I develop against something if I don't have a search appliance, and how much will it cost for me to get one? So the appliances themselves are actually priced. There's a range starting at just under $2,000 for the starting Google Mini, and then it goes up based on the size of the index, so the number of documents that are in the index. So as a developer, right, so a small company, depending on the size of their content, they could probably do very well with a Google Mini. Some of the APIs here are actually not supported on the Mini. Our Google Search Appliance, which is our yellow box, the Mini is a blue box. So you can kind of tell the difference. But for the most part, the functionality and the platform is the same. It's really it's a difference in the capacity of the index, and there is some functionality differences. A lot of the security stuff, the authorization, authentication, if you've got complexities in that area as a small company, then you probably want to start with a Google Search Appliance, which starts at $30,000 and then kind of goes up from there. But as a developer, so this is a good question. How do I develop against this stuff? Do I need to shell out $2,000 for a Google Mini to be able to develop against these APIs? And that's certainly one way to do it for a lot of companies. That's not a high starting cost. But certainly in the context of Google Developer Day, you've got all these APIs and all this stuff available for free. How do we provide enterprise search available for free? And there's a few simulators and that kind of thing on our website, both open source and sort of binary simulators that allow you to simulate these various APIs. What we're actually working on is trying to find ways. We're actively working on trying to find ways that we can provide this functionality, not the hardware would cost us money, but provide the functionality so that developers can do development and basically have a full simulation of like, I've got documents, I want to put them in the index, then I want to create a front end on top of that, and I want to kind of see how things get displayed and so forth. And so we're working on ways to make that, to improve our simulation and sort of make that such that you can do full development all for free. Yes?
One of the questions I had was the Google SOAP interface has gone away, and I've worked at a company that had the GSA or the GB1001 and had really good success with it. But I'm currently working at another company that has even more documents than the 5005 could index. So we were wondering if there was, any kind of like, is the SOAP API, is there something going to be that's going to be replacing that, or is there ever going to be maybe a hosted solution that does something like this, or what happens when you move past the document limitations of, and maybe there's this stuff that we don't know about out there.
Yeah. So the document limitations, we actually don't have document like index limitations. Effectively, we've got a certain number of documents that we have price books up to, and it goes into the millions. It was like 30 million or something documents. And then beyond that, if you've got a corporation with a huge index, we'll actually work with you to build a custom solution to expand that index. So that shouldn't be an issue. As far as the SOAP APIs, the search appliance and our enterprise search, we've never provided SOAP APIs. Google.com provided a SOAP interface to its search index, and so that's what kind of has gone away and been replaced by what we feel was an easier API that was easier to work with. And then the other part of your question was about hosted and that kind of thing. We're definitely looking at ways to provide our functionality in all kinds of different deployment models. As you can already tell with our search appliance, this is an in-house appliance. We've got all the Google App stuff is all hosted. We've got some of the Earth and Map stuff is kind of a combination of the two. So we're working on different business models and constantly trying to flesh out what are the use cases and what's the demand, and then we're certainly open to moving in one direction or another based on that. Yes.
So you talked about how you can do search even if some of the documents are restricted to only certain people can see them to make sure the user is authenticated.
Right.
My question is, what happens if the amount of documents a person can see is a small percentage of perhaps the search results? So you might have to do hundreds or thousands of requests before you got a few that would work. Are you worried about, is the performance still okay in that sense, or if performance was important, are there certain workarounds that can be done for that case?
It's another great question. So I mentioned that when you do a search, a secure search, it's going to the appliance is going to figure out these are the top candidate results, and then it's going to have to figure out for each result, can this user access this result? And so in the worst case, you could say we get back 1,000 results, and the user can only actually access results 990 through 1,000. In that case, performance would definitely not be. In that case, we would basically have a situation where user would be waiting. What we found, though, is that that's generally not the case, because the relevancy of results not necessarily associated with the user's authentication credentials and so forth. And so if they could truly see, there's not many scenarios where of the top 1,000 results, user only has access to 10 results, number one, but also the least relevant 10 results, number two, because chances are there's going to be other users that have that same level of access. This is usually kind of, the broadest part of the user segment. And the relevant documents are going to be relevant. They're relevant for a reason, because they're useful to a wide variety of users. And so I think that's probably why that we haven't run into that case, but that's definitely something to watch out for and say, hey, if we for some reason our corpus is a little bit skewed in that direction, then performance could be an issue. What you could actually do as a workaround is you can create, remember I mentioned these collections? You can actually create a slice of the index, a collection that is specifically tailored to this population that's going to run into this problem, and then have your searches, instead of going against the entire index, have it go against that slice of the collection. And then they can search against the rest in like maybe a different search box, maybe it's a user option, something along those lines.
Yeah, you had mentioned the crawler pulls back the metadata from various content that you would be indexing. Is there a level for like a local content manager to edit the metadata in the index rather than, it seemed very code intensive. I don't know too many content managers that would be able to post
Right, you'd basically want to set up effectively we call it a connector, but this module that's going to go and pull that information out of on a schedule, pull that information out of the content management system and feed that into the appliance. You can't edit the index directly, but you can, that feed, if you look closely on that feed XML, it had an add attribute. So basically you can incrementally modify the index and say, okay, I want to add these documents, now I want to delete this metadata, now I want to insert this metadata instead. So you can over time manage that by basically setting up this connection between your content management.
And then what about the situation where in a content manager, like what you're showing there, when you have a PDF with a guy's resume and then a profile, somehow I would like to be able to, without gaming the system, I mean, I think we do that with regular Google search results, what kind of keywords or organization do I need to have to make sure the documents show up 1, 2 in the search result? Is there a way to like bind that, or is that the technique you were showing earlier about grouping them?
As far as like tweaking relevancy so that they show up?
Yeah, so, because I mean, I would want the Ben Franklin's profile, and then I want his resume right after that.
Yeah, so you can separately, there's actually a feature, separate of the APIs is a feature, because this is really be an administrator type of a thing, right? As an administrator, I want to decide which documents are more important. And you can actually tweak, you can't really have control over the relevancy, because that basically adds a lot of complexity to the user. We don't want to really allow people to have full control. But you can actually tweak and say, okay, for these documents that are on this server and this application, I want to kind of bump up the relevancy a little bit, and for these, I want to bump down the relevancy. So that might help with that situation. We need to actually wrap it up. So let's say this last question. I'm getting the cutoff from the back of the room.
It sounds like the pricing is basically per document or record. And I'm wondering about a situation, I mean, that's fine for resumes and papers, but what if I've got a database that's well normalized and I've got a pile of tables with just a few fields in each?
Right, and so you worry about the licensing costs?
Is that, I mean, it doesn't seem fair that 3 words is going to cost me the same as 1,000.
Yeah, your database record would effectively wind up as a document, as a result in your search index. Typically what we found, because the databases have their own index, and they do quite well in indexing their own data, that type of, that level of structured data, typically what we found is that you can use one box for that. And so we can actually call out and basically delegate the relevancy to the database management system. In your one box module, you can have some logic that kind of tweaks that a little bit and say, okay, we want to show this, we don't want to show this. We want to show a link to so the user can actually go in and run this query directly in the database rather than showing the results in line. So you can do things like that. That's typically been the approach for folks that are worried about having a large number of records, each with a small amount of data, and worried about cost. Okay, I think that about wraps it up. I want to thank you all for coming, and enjoy the rest of the sessions this afternoon.